Here's another example. Find the domain of the function f of divided by g of x, so another division problem. But now we've got two radical functions. Our last example we had two radical functions, but we were adding them together. So we just had to find the domain of each one and see where they overlap. This problem is going to be very, very similar. One slight difference, we've got a denominator now. So if I put f divided by g of x, again, just kind of into context here, remember that means f of x divided by g of x. Now let me just go ahead and put that out. So f of x square root of x and g of x square root of 12 minus x. So here's our combination, our algebraic combination of functions we're interested in, and this is what we want to find the domain of. Well, we know the denominator cannot equal 0, so that's something we have to consider. We also know that under both of these radicals, we can't have negatives. So let's go ahead and put that together. So square root of x has to be positive, right? And so let me just do this. Instead of doing square root, let's just say, well, x has to be greater than or equal to 0. That would make this positive, so that's pretty easy. There's nothing to solve for there. 12 minus x has to be greater than 0. It can't be equal because it's in the denominators, and so we can't divide by 0. So now if I solve this thing, I get negative x greater than negative 12. So if I subtract that 12 over, then if I divide my negative through, I get x is less than 12. Remember, I have to reverse my inequality symbol when you multiply or divide by a negative. So here's our two intervals. We're greater than equal to 0. We're less than 12. Let's draw that and just kind of picture what's going on there. So I've got 0 and 12. So we can be greater than or equal to 0. So I can be everything that way. I could be less than 12, so I could be everything that way. Well, where do they overlap? So looks like they share 0 in common up to 12. So we can go from 0 to 12, not including 12, because one of them doesn't include that. And there is our domain.